Hey girls, welcome back. I hope you learned a lot about standard form of linear equations and the intercepts of linear equations, how to find them on a graph, a table, and from the equation algebraically. Today we're going to be talking about how to find and interpret something called the rate of change. So the key idea here is that if x is the independent variable and y is the dependent variable, then the rate of change is the change in the y values divided by the change in the x values. This little Greek letter right here, it looks like a triangle. It's called the Greek letter delta. It means change in. You'll probably see it in chemistry again if you haven't already seen it this year in biology or whatever science class you are taking. Rate of change is often abbreviated with the letter m, and the formula we use to find it based on any 2 points on a line is y2 minus y1 over x2 minus x1. The y2 minus y1 is going to give you the difference in the y values, or in other words, the change in the y values. And the x2 minus x1 is going to give you the change in the x values. How far apart are those two x values? Once you figure out how far apart are the y values, how far apart are the x values, you divide them or you leave it as a ratio, like a fraction, to tell you your rate of change. Now you can switch this up. If you want to do the first y minus the second y, that's fine. You just have to keep it matching on the bottom. So if you do the first y minus the second y on top, you have to do the first x minus the second x on the bottom. Just like we were talking about making note cards for your standard form equation, I would make a note card for this rate of change equation because it's something you'll have to have memorized. You have to know how to find the rate of change, or in other words, the slope of a line. One thing that a lot of people mess up on that equation is they either mix up, they do y1 minus y2, and then they accidentally do x2 minus x1. They switch those orders on the top and bottom, or they'll flip it upside down and have the x's on top, the y's on the bottom, which is also incorrect. Those are the most common mistakes we see here, so just memorize your equation and you'll be good to go. Let me show you an example of rate of change. Let's say we were looking at this table giving the number of computer games and the total cost for those computer games, and we wanted to find the rate of change and explain its meaning. You can pick any 2 points on this table to call them x1 and y1, x2 and y2. So you could have also used the third point, but I just chose the first two because they were the smallest numbers on this table. Once you pick your x1, y1 and your x2, y2, then you're just going to plug those numbers into the formula that we talked about above. So write down the formula to help you remember what it is, and then work down your paper. So wherever you see y2, you're going to replace it with 156, y1 you replace with 78, x2 you replace with 4, and x1 you replace with 2. Now remember, in a fraction, you technically have a parentheses here around the top and a parentheses here around the bottom. It's just not always written. So that means that we have to subtract these two values first. So we get 78 on top, 2 on the bottom. Then we can divide or reduce. 78's even, so I know it can definitely divide by 2. If you need to use your long division to figure that out, you can. It should give you 39. So it's saying the slope, or the rate of change, is 39. Basically, what the rate of change tells you is the change in y over the change in x. Another way to say that for this problem is the cost per game. So we would be looking at each game costs $39. You're going to want to use the unit from the table over here. So you could say it like that, or you could say it costs $39 per game. It's always y per x for the rate of change. So go ahead and try the next one and see if you can interpret that meaning. Here's what your answer should be for this one. The rate of change is 16. And what that means is that each floor tile is 16 inches squared, or you could say it as it's 16 inches squared per floor tile. Remember, it's always y per x for rate of change. Like I mentioned, slope is another word for rate of change. On a graph, a steeper line represents a larger value for the slope, a larger absolute value. So now it could be a bigger negative number, like a negative 10 is a steeper line than a line with a slope of negative 2, because negative 10 is a bigger absolute value than negative 2. So the bigger absolute value of the slope, the bigger that is, the steeper the line's going to be. Linear functions, they always have a constant rate of change. So what that means is that no matter where you look, no matter what 2 points you choose on the graph, it's always going to give you the exact same rate of change because of how it's a straight line. So let's take a look at some examples of that. Let's figure out, are these linear or nonlinear, and explain our thoughts. If we're looking at this table and we need to determine whether it's linear or nonlinear, we're looking at the change in y over the change in x. So you might notice here that the change in y every time, it's going down by 2. The change in x, it's always going up by 3. So this is linear because it has a constant slope. It's always negative 2 over positive 3. Negative 2 over positive 3. Negative 2 over positive 3. Since it's the same thing for every point, it's a constant slope. That means it's linear. Whereas on example B, you'll notice it goes up by 2, then it goes up by 4, then it goes up by 2, then it goes up by 4. Let's take a look at the x's. All the x's are always going up by 2. 2 over 2 is not the same thing as 4 over 2. So since it's not always the same rate of change, this is a nonlinear function because it's not a constant slope. Go ahead and see if you can try out this idea on the next page with the practice problems and the extra example. Here are the answers for those practice problems. The first one, A, is nonlinear because it's not a constant rate of change, whereas B is linear because it is a constant rate of change. The slope for the function represented by the table in B, it's 5 over negative 3. So the rate of change is always 5 over negative 3, or the slope is always 5 over negative 3, meaning that it is a linear function. Now looking at this extra example, you'll notice that the change in y, it goes plus 10, plus 10, plus 20, plus 10. Just because the change in y isn't always the same doesn't automatically mean that it's nonlinear. Remember, slope looks at the change in y divided by the change in x. So looking at the change in x, you'll notice it's adding 1, adding 1, adding 2, then adding 1. When we look at the change in y over the change in x, it is always the same no matter where we look. 10 over 1 is the same thing as 20 over 2. So this one does represent a linear function because the rate of change is constant. So you have to pay attention. Remember, rate of change is change in y over change in x, not just one or the other. You have to divide it out or look at the ratio to tell whether it's a constant rate of change or not. It's important to notice that a slope can be positive, negative, 0, or undefined. Remember, undefined is when you have 0 on the bottom of the denominator. So if it's like any number divided by 0, that's when you get undefined. So if the change in x is 0, that's undefined. Whereas if the change in y is 0, 0 over any number, that equals to 0. So when you're looking at these numbers, positive, negative, 0 are defined as the slope, that tells you something about the graph. A positive slope means that the graph is going up or increasing when you look at it from left to right. A negative slope means that the graph is going to be going down or decreasing from left to right. A 0 slope, since the change in y is 0, that means the y value is not changing at all, so it's a horizontal line from left to right. And an undefined slope means the change in x, the x value is not changing at all, so that makes a vertical line. An undefined slope is a vertical line. Think of it like if you're looking at a mountain, you're never going to have a straight up and down mountain. So you can't have a slope that's that steep, that's just undefined. It's not possible. If you have to classify a slope as positive, negative, 0, or undefined, you have to find the slope first. So for example, if you wanted to find the slope between -3, -1, and 2, -1, you can either use the equation and plug in your numbers. Remember, subtracting a negative is the same thing as adding. So on top, you have -1 plus 1, which makes 0. On the bottom, you have -2 plus 3, which makes 5. But 0 divided by 5 is always 0. So that means that these 2 points between them is a slope of 0. That's telling me that it's a horizontal line. The other way you can do it, besides looking at the equation, is graphically. If you plot those 2 points on a coordinate plane, you'll notice that they make a horizontal line, which automatically tells you it's a 0 slope. The change in y is 0, so the slope is 0. Now, if you're looking at it as a table, you can do the same thing. If you wanted to make it a graph, you could, and look at it visually. Or you can use your points and plug them into your equation. Same as last time, when you're subtracting the negative, it makes it plus. So on the bottom, you should have 2 plus 3, or 5 on the bottom. On top, you have -3 minus 4. Since they're the same sign, you add their values, 3 plus 4 to get 7, but you keep the negative sign in front. A negative over a positive is equal to a negative, so these 2 points would have a negative slope. If you graphed those 2 points, -3, 4, and 2, -3, on a coordinate plane, you would notice that the line is sloping downward. I want you to try a couple more of these on your own, pause it, and then resume and see if you got them right. Here are the answers to those 2 practice problems. The first one is a positive slope of 2. The second one is an undefined slope because you got division by 0. Alright, our last example here for slope is going to be a little more challenging. It's going to be giving you the slope this time and having you figure out what is the point that is missing. So it says find the value of r so that the line through 1, 4, and -5, r, that y value is missing. We want these 2 points to have a slope of 1/3. If you want to do this using algebra, you can plug in all of these values to the equation for slope. I know 1/3 is the slope, so when I go to put my formula together, I'm going to replace m, the slope, with 1/3. In the formula, y2 is r, y1 is 4, x2 is -5, x1 is 1. I can only simplify the denominator here. -5 minus 1 makes -6. Now to solve this, I'm trying to get r by itself in order to figure out what is the value of r. I want to find the value of r. So if I have r minus 4 divided by -6, I want to undo dividing by -6. I'm going to multiply both sides by -6. Multiplying the left side by -6, you can do that by taking -6 over 1 multiplied by 1 over 3. That gives us -6 over 3, which reduces down to -2. On the right side, my -6 and -6 cancel each other out, so I'm just left with the numerator r minus 4. Now that I just have r minus 4 on the right side, I can add 4 over to get the r by itself, and I figure this out. -2 plus 4 is 2, so my r value would have to have been 2 to make that a slope of 1/3. Okay, on your own, I want you to try the practice problem. That's exactly the same as this. See if you can set it up and solve it for the value of r. This one did not work out as nicely, but once you plug in the values to the formula, you should be able to solve it and get r by itself. You have to, this time, since r is in the denominator, multiply the entire both sides by 5 minus r. It's kind of like you're doing that cross multiplying. And then you're going to have to distribute this time. And you end up getting a fraction, 19 over 4. You can make it a mixed number if you want, 4 3/4, or you can even make this one a decimal, 4.75, if you'd like that better. Alright, hopefully you learned a little bit about slope today, looking at the slope of a graph, a slope of a table, or the slope between just 2 coordinate points, and how that looks on a graph, whether it's positive, negative, 0, or undefined. Next, we're going to learn a little bit more about writing and graphing linear equations in another form besides standard form, something called slope-intercept form. I look forward to seeing you then. Bye, girls.